So getting back into the swing of things, we have 3.4. It's our rational zeros of polynomials. You guys will have 2 web assigns. I split it up so it wasn't a ton of stuff in one night. You have the first part tonight, it's due tomorrow. The second part is Tuesday, due on Wednesday. Then we're going to practice on Wednesday, take our quiz on Thursday, and move right along. When I talk about rational zeros of a polynomial, guys, zeros, it's the same thing as saying, write this down, roots, solutions, and x-intercepts. All right, when they ask you for the zeros, the first thing you always want to try and do is factor. All right, we've done this a jillion times. Anything new today is just this first thing when I say P over Q, and then that's it. Everything else is going to be stuff that you guys have seen before. It's just putting a lot of stuff together. But when they ask you for the zeros of the polynomial, they want to know what x equals. We're going to do something today called P over Q, okay? P is the constant. It's the last number when the function is written in standard form. And Q is the coefficient of the leading term. In our case, for college algebra, not for just Miss Meadows' class, for Miss Glick as well, but for our case, the Q is always going to be 1. It's always going to be 1. Now, in math all the time, it's not always 1. But for our purposes, our Q is always going to be 1. So, in a sense, the only thing you really have to focus on is that last number of the equation, okay? So, I'm going to do an example. I'm going to walk you through it. Then we're going to talk about everything that we did. Excuse me. And then you guys are going to be good to go. So if I say to you, you get the question, it says, find all the rational zeros. First thing I want you to do is the equation written in standard form, right? Highest exponent to the smallest, yes. The highest exponent tells you the number of zeros. That's how many x equals you should have. So if you have x to the third, that means you should have x equals something, x equals something, x equals something. So in this case, if I said to you guys, okay, go ahead and factor this. Can you factor? Can you factor x cubed minus 3x plus 2? Yeah. To what? You're thinking of it to the second power, which is a lot of times what we're looking at. But this isn't to the second power, it's to the third. So there's nothing we can do. We can't say something times something gives me x cubed. It doesn't work like that. So this is where our P over Q is going to come in. This is the rational zero theorem. I'm only really worried about my P, this last number. So what you're going to do, follow along with me, guys. When you can't factor, you look at that last number and you write it. You think to yourself, okay, I have the constant 2. Let's list all the factors of 2. What times what gives me 2? 1 and 2. That's it, right? Now, we have to say all the possible factors. If I have 1 and 2, okay, that's fine. But could it also be -1 and -2? So you have to account for the plus and minus every single time. On WebAssign, like the first 2 or 3 questions say, list all the possible factors. You guys would say -1, +1, -2, +2. You have to write out the negative and the positive. For me, I'm perfectly fine if you guys just put plus minus in front. That's fine. This is cool. But for WebAssign, you have to have the plus and minus in front. So once you determine what all the factors are, you just use synthetic division to figure out which one quote unquote works. If I use synthetic division and my remainder is 0, what does that tell you about that factor? Does it work or not? Yeah. So I'm going to tell you guys, you're going to have to do synthetic division. You might have to do synthetic division more than once. I always start with +1, and then if that doesn't work, I go to -1. And then if that doesn't work, I go to 2. And then if that doesn't work, I go to -2. Some of you are going to say, well, I want to just start and try with -2. Okay, do whatever you want. I'm just trying to show you what I think is the easiest way and the most time efficient way. I'm going to start with 1. I'm going to see if 1 is a factor for this polynomial. So when I do that, I write 1 in my little box, and then I write out all the coefficients of my polynomial. So the coefficient of x cubed is 1. What's the coefficient of x squared?
0.
0. Good. There is no x squared, so I have to have a placeholder. The coefficient of x is -3, and then my constant is +2. You guys with me? Okay, synthetically divide. Bring down the 1. The coefficient of x cubed. Yep. Good question. All right, so synthetically divide. 1 times 1 is 1, and 0 plus 1 is 1. 1 times 1 is 1, and -3 plus 1 is -2. -2 times 1 is -2, and 2 and -2 gives me 0. You guys agree? So what did you just prove to me when we just did that synthetic division? That 1 works. That means 1 is a factor. So I'm going to go over here and I'm going to say, okay, x equals 1. I know one of my zeros is x equals 1. How many zeros should I have? How many x equals should I have? 3. We said good. We said at the beginning. So now I have 1, 1, and -2 left. How do I write a polynomial with those numbers? 1, 1, and -2. Anybody remember? Since we started off with the third, yes, that means my answer is x squared. This is x, and this is my constant. So I'm left with x squared plus x minus 2 equals 0. Now in this step, not all the time, but a lot of the times this works out like, oh, I think I can factor this. I don't have to do synthetic division again or anything. All right, so can I factor this? Do I know factors of -2 that'll multiply to give me -2 but add to give me 1? +2, -1, you guys agree? So now I say x equals -2 and x equals +1. So I have x equals 1 again, and I have x equals -2. These are my zeros. I'm not going to ask you this on the quiz, but you guys should be able to tell me something about x equals +1.
So wait, Miss Meadows.
Mm-hmm.
So out of the possible solutions, you know how you have -1, 1, and -2 and 2?
Yeah.
So we pick one of them, and we
try synthetic division. And if it doesn't work, pick another one.
And if it's 0, that means it works, right?
Correct.
If our remainder is 0.
Correct. What do you guys know about x equals 1? I have it how many times? Twice. That means there's multiplicity. All right, now I'm going to teach you a vocabulary term that you're going to have to know. You're going to have to answer this question on your quiz 2 different ways. You're going to have to tell me what the zeros are. And then you're going to have to tell me what the linear, whoops, if I could spell, it'd be awesome, linear products are. Oh my gosh. What is this awful thing she's going to make us do? Super easy, all right? The way you find out your linear products, write your zeros. All right, we're going to go a step backwards. Your linear products are going to be 3 or 4, however many zeros you have, little binomials. So I'm going to have this binomial, this one, and this one. If I was going to go one step backwards, if I moved this +1 over here with the x, what does it become? So this would be x minus 1. If I take this +1 and I move it over here, it becomes x minus 1. If I move this -2 over here, it becomes x plus 2. Those are your linear products. That's it. Nothing more complicated to that. So you're going to have to answer on WebAssign. It'll probably say, what are the zeros? And then write your answer as linear products. That's all they mean. They want the binomials. What it would look like one step before you solved. Does that make sense? All right, now you guys might, hold on one sec, okay. You guys might get to where you have like, say, x squared plus 4x minus 9. Then you have to factor. Is this going to factor? No. Is there a formula that we know to use when we get to a quadratic and it doesn't factor? The Pythagorean theorem, right? That is a possibility. I don't have any on the examples, I don't think, but I know on some of the examples we're going to do Wednesday, there's some that just don't factor, and that's just, you know, but you guys know how to do the quadratic formula. Duque, question in the purple. When you divide, if I was going to divide my polynomial of x to the third, right? If I, x goes into x to the third, how many times? Right? If I divide x cubed divided by x, If I divide x cubed divided by x, it equals x squared, doesn't it? So every time you do synthetic division, whatever degree you start with here, your answer on this line is always one less. Mm-hmm. So since we start off with x to the third, after I divided, that's in a sense I'm dividing x into x to the third, so that's where we get our x's squared. Let's do another one. Look, this slide just says in words what we just went through, how to do the whole process, but I think it's easier once we do it. Let's do these two examples. I'm going to do 1 and 2 now, and then we'll do 3 tomorrow. Okay, so the first thing I'm going to do, if I'm listing all the zeros, that means the solutions, the intercepts, the zeros, all means the same thing. It means to factor. So factor, they want us to factor this. If I look at this first example, guys, x to the fourth plus x cubed minus 6x squared minus 4x plus 8. Do I know how to factor that? But I don't have any like terms. I can't take anything out, nothing. I can't factor that. I don't know how to factor x to the fourth. What I do know is I can say, okay, how many x's should I have? How many x equals should I have? 4. So we're going to have to do our P over Q, guys. Look at the last number. What is the last number? 8. P over Q is the last number over the coefficient of the leading term. So it's 8 over 1, so it's just 8. So we have to list out the factors of 8. I have 1, 2, 4, and 8, correct? Do I have just the positive ones? No, so what do I have to put in front? Plus and minus, okay? So on WebAssign, you have to put in positive 1, negative 1, positive 2, negative 2. For me, all you have to do is write the plus and minus in the front. Now, you're going to do synthetic division to find one of these factors that quote-unquote works to have your remainder 0. You don't have to start with 1. Tommy could start with positive 2. Kyle could start with negative 8, just see what works. I personally just always start with positive 1 and then go to negative 1 and then positive 2, just because I like to keep the same process every time. I don't skip anything. I don't waste time. So I'm going to just start with positive 1 and see if it's a factor. The way that I do that is I synthetically divide. So I have 1. What's the coefficient of x to the third? 1. What's the coefficient of x squared? Negative 6. What's the coefficient of x? Negative 4. And what's my constant? 8. Okay, perfect. We all know how to do synthetic division. Take your time so you don't make any silly mistakes with signs. But you bring down that first number, and then 1 times 1 is 1. 1 plus 1 is 2. Multiply to the corner. 2 times 1 is 2. Negative 6 and 2 is negative 4. Negative 4 times 1 is negative 4. Negative 4 and negative 4 is negative 8. Negative 8 times 1 is negative 8. And then 8 and negative 8 is 0. So what did you guys just prove to me? One of my factors is what? 1. So I'm going to write over here x equals 1. I'm even going to circle it so I don't lose it in my work. Now, was it wonderful that each time we did this, 1 worked? Yes. Is it going to happen like that all the time? No. But what is my resulting polynomial? 1, 2, negative 4, negative 8. What does that tell me? What did I start off with? What my polynomial was x to the what? 4th. That means I start 1 degree less. X cubed, x squared, x, constant, and my remainder. So I'm left with x cubed plus 2x squared minus 4x minus 8 equals 0. Now, we can go ahead and just do synthetic division again. But we know how to factor when we have 4 terms, don't we? What do? Group. Let's group the first 2 and the second 2 and see if anything helps us out here. What can I take out of x cubed and 2x squared? Okay, I'm going to take out an x squared, and I'm left with x plus 2 inside. Agreed? Good. Now I look at the next one. What can I take out? Negative 4, and then I'm left with x plus 2 on the inside. So did grouping work for us? Yes, I take out that common term that they have of x plus 2. That's gone now. And what's left over? x squared minus 4 equals 0. I cannot factor x plus 2 anymore. Just going to stay. What can I do with x squared minus 4?
Difference of squares.
It is the difference of squares. So it's x plus 2, x minus 2. What are all my other x's, guys? X equals negative 2, x equals negative 2, and x equals positive 2. I have 1, 2, 3, and there's my fourth. So to answer this question, the two different ways that you're going to be asked, your zeros, your solutions, your roots, your x-intercepts would be x equals negative 2, negative 2, 1, and 2. You can write x equals, x equals, x equals, x equals if you want to. That's fine. But those are your zeros. And then if you were going to write them as linear products, you don't have to do this step that I'm going to right now, but just so you guys can see it a little easier, I'm going to write it for right now. Because linear products just means I want a binomial. So this would become, if I move this negative 2 over, it becomes what? X plus 2. Move this over, it becomes x plus 2. Move this 1 over, it becomes x minus 1. Move this 2 over, it becomes perfect. And there are your linear products. Questions? We'll do the third example on tomorrow. I just want you guys to get the hang of it. All right, so I start off here with x cubed plus 5x squared minus 2x minus 24. First of all, how many x's should I have? 3, because x cubed is my biggest exponent. Now, I have 4 terms here. Before I start to do any P over Q rational theorem, I'm going to try and group it just to see. Maybe I don't have to do all the synthetic division. I can take out an x squared, and I'm left with x plus 5. If I take out negative 2, I'm left with x plus 12. Uh-oh, does grouping work? Yes or no? Nope, grouping doesn't work. So that means we have to do P over Q. Oh, geez. What's the last number? What's the constant? Oh, hold on a second. Okay, we're back. What's the last number that I see? Negative 24. Ay. Factors of 24, guys. 1, 2, 3, 4, 6, 8, right? 12, 24. What goes in front of all of those numbers? Plus or minus. So on WebAssign, you would have to actually type in positive 1, negative 1, positive 2, negative 2, positive 3, negative 3, and so forth. Now, I'm not asking you to do synthetic division 127 times. We're just going to do it until it works. Now, some of you are going to say, I'm just going to start with 4 and see if it quote-unquote works. The problem with that, guys, is say you start with 4, and then you try, negative 8. Then you go to positive 2. If you kind of just do that and get yourself lost, you're going to lose time. These problems aren't incredibly difficult, but they are a little time-consuming. So I would start with positive 1 and just see if it is a factor. If it's not, move on to the next one. So coefficients of my polynomial is 1. Coefficient of x squared is 5. Coefficient of x is negative 2, and the constant is negative 24. Synthetically divide, bring down the 1. 1 times 1 is 1. 5 plus 1 is 6. 6 times 1 is 6. Negative 2 and 6 is 4. 4 times 1, is this going to work? Does negative 24 plus 4 give me 0? No, it gives me negative 20. So you just told yourself right there, okay, positive 1 doesn't work. So if positive 1 doesn't work, let's try negative. Maybe that one will work. Coefficients, 1, 5, negative 2, negative 24. Bring down the 1. 1 times negative 1, negative 1. 5 and negative 1, 4. 4 times negative 1, what? Negative 4. Negative 2, negative 4, negative 6. Negative 6 and negative 1, 6. Is this one going to work? Nope, this one doesn't work either. So you can just say, okay, now let's try 2. Again, coefficients, 1, 5, negative 2, negative 24. Bring down the 1. 1 times 2 is 2. 5 plus 2 is 7. 7 times 2 is 14. Negative 2 and 14 is 12. Uh-oh. What's 12 times 2? 24. What's negative 24 and positive 24? 0. What did you guys just tell me? 2 works. So I'm going to say x equals 2. That's one of my solutions. Now, go up to the front. We said again we needed 3 x's, right? Okay. So let's look at my leftovers. Let's see if I can factor this, if I can write it out. So I have x squared. This is x. This is my constant. So you have x squared plus 7x plus 12 equals 0. Before I just jump into synthetic division again, can I factor this? Are there factors of 12 that'll multiply to give me a 12 but add to give me 7? Yes, x plus 3 and x plus 4. So my x other values would be negative 3 and negative 4. So say at the beginning, Bridget said, I'm going to just try negative 3 and see if it works. If she started off with negative 3 in synthetic division, would she have gotten 0 as a remainder? Yes or no? If I found out that x equals negative 3 is one of my answers, that means my synthetic division should work when I use negative 3. So if you don't go in order, quote unquote, like I'm telling you, you can still get the right answer. I'm just worried about time and you guys getting yourself confused. But here are my 3 zeros. These are my answers. When I say to you, what are the zeros of the polynomial, solutions, root, x-intercepts, it's x equals 2, x equals negative 3, and x equals negative 4. Now, another thing you're going to have to answer is your answer as a linear product. Well, that just means what's the binomial? What did my x look like that step before I went and solved? So you would write your linear products as what? X minus 2, x plus 3, and x plus 4. Great job. Perfect. Now, this one we're going to do tomorrow, look at the last number, 60. There's lots of factors of 60, aren't there? Okay, so this problem's just going to be a little longer, but that's okay. There's only 3, but you're going to have to write out all the factors, and then you have to be like, okay, does 1 work? Does negative 1 work? Does 2 work? Does negative 2 work? You got to find one that works. Then once you find that one that works, generally you're able to factor at that point. And if you can't factor, then you use the quadratic formula.